French and Raven identified 5 sources of personal power that people draw on at work. Legitimate power that comes from a formal title or position, for example, a manager. Reward the ability to give something desirable such as raises and praise. Coercive the ability to punish or withhold, for example, demotions and negative feedback. Expert power that stems from specialized knowledge or skills, the IT guru who can fix a system. Referent power that is rooted in personal charisma or relationships, the colleague everyone admires. Organizational implications. Legitimate power keeps the hierarchy stable, reward and coercive power drive compliance. Expert power boosts innovation, referent power enhances culture and loyalty. Quantitative assessment managers can assign a score 0 to 5 to each base for every employee, then compute a weighted index. Power index sub I equals WL times L sub I plus WR times R sub I plus WC times C sub I plus WE times E sub I plus WREF times ref sub I, where the W's are strategic weights. For example, WE higher in a tech firm. The index can be correlated with performance ratings to see which bases actually predict results. Influence tactics are the concrete actions people use to exercise power. They fall into 3 broad groups. Hard tactics, rational persuasion, pressure, coalition building, and upward or downward appeals. These work best when the target has clear rule-based expectations, for example, a compliance audit. Soft tactics, ingratiation, inspirational appeals, consultation, and personal appeals. These are most effective when the target values relationships or shared identity, for example, a creative team. Indirect tactics, exchange and legitimation, useful when the influencer wants to hide the power source. Contingency factors include the target's power level, the urgency of the request, and the history of the relationship. For example, a high-power target responds better to rational persuasion, whereas a low-power target may be swayed by ingratiation. Effectiveness scores can be captured by asking followers to rate each tactic's success on a scale of 1 to 5. The average score across situations yields a simple effectiveness index. Effectiveness sub T equals sigma score sub T divided by N sub T. Higher scores signal tactics that should be part of a manager's personal toolkit. Explanation. The Power Influence Interaction Matrix, abbreviated PIIM, helps leaders match their primary power source to the most suitable tactic. Imagine a 3x3 grid. Rows are power source, legitimate, expert, referent. Columns are tactic cluster, hard, soft, indirect. Each cell contains a recommendation and a probability of success derived from past data. To turn the matrix into a decision tree, start at the root with the question, what is my dominant power source? Branches then ask, is the situation urgent, and what is the target's power level? The leaf nodes give a concrete tactic. For example, expert plus high urgency leads to rational persuasion. The tree can be quantified. Each leaf has an expected success probability P sub ij. Overall expected success for a chosen path equals the product of P sub ij, allowing managers to compare alternatives mathematically. Social network analysis, abbreviated SNA, treats the organization as a graph where nodes are people and edges are work-related ties, such as information flow, advice, and collaboration. Degree centrality measures how many direct contacts a node has. CD of I equals K sub I divided by N minus 1, where K sub I is the number of ties for person I and N is the total number of employees. High degree often signals a hub for day-to-day coordination. Betweenness centrality captures how often a node sits on the shortest path between 2 others. CB of I equals the sum over S not equal I not equal T of sigma sub ST of I divided by sigma sub ST. Sigma sub ST is the total number of shortest paths from S to T, and sigma sub ST of I are those that pass through I. A high betweenness score identifies brokers who can control information diffusion. Influence diffusion can be modeled with a simple linear threshold rule. A node adopts a behavior when the weighted sum of its neighbors' influence exceeds a personal threshold theta. Sub I adopt sub I equals 1 if the sum over j and n of I of w sub ij times adopt sub j is greater than or equal to theta sub I. By simulating this process, analysts can predict how a new policy or innovation spreads and which actors to target for maximum impact. To measure how much influence different stakeholders hold, start with a well-designed survey. Use a 5-point Likert scale, 1 equals strongly disagree, 5 equals strongly agree, for statements such as "my opinion shapes project priorities." Collect responses from a representative sample of employees, customers, or partners. Reliability is checked with Cronbach's alpha. Alpha equals n divided by n minus 1 times 1 minus sigma var of item divided by var of total, where n is the number of items. Values above 0.70 indicate acceptable internal consistency. Validity can be examined via exploratory factor analysis, EFA. Extract factors, retain those with eigenvalues greater than 1, and look at factor loadings greater than 0.5 to see if items group into logical dimensions. For example, decision-making influence, resource influence. The resulting factor scores become quantitative measures of stakeholder influence that can be linked to outcomes like project success rates. Network building is not just about adding contacts. It's about bridging structural holes, gaps between otherwise disconnected groups. An individual who occupies a brokerage role across a structural hole can command information premiums. The expected return on investment, or ROI, of a networking activity can be estimated as ROI equals P opportunity times V benefit minus C time minus C resources, where P opportunity is the probability that the new link leads to a lucrative deal, V benefit is the monetary value of that deal, and C star are the costs of attending events, maintaining relationships, etc. For example, if attending a conference costs $2,000, the chance of landing a $50,000 contract is 5%. The expected ROI equals 0.05 times 50,000 minus 2,000 equals $350. Positive ROI signals a worthwhile networking investment. Using power ethically requires weighing the benefit to the organization against the risk of abuse, a classic moral hazard problem. The expected utility of a power-based decision can be expressed as EU equals P times U of benefit plus open parenthesis, 1 minus P close parenthesis times U of negative cost, where P is the probability the power is used responsibly, U is a utility function, for example diminishing returns, and cost captures reputational damage or legal penalties if power is misused. A cost-benefit equation helps managers decide. Net value equals sum of positive impact I minus sum of negative impact J. If net value is less than 0, the power move should be rejected or mitigated with controls, for example oversight committees. Embedding such calculations into policy reviews promotes transparent and accountable use of influence. Team decisions are often a game of strategic interaction. Using a simple two-player payoff matrix, each member can choose to cooperate, share information, or defect withhold. Example matrix. Cooperate versus defect payoffs. Cooperate gives 3-3, cooperate defect gives 0-5, defect cooperate gives 5-0, defect gives 1-1. If both cooperate, they each get 3 mutual benefit. If one defects while the other cooperates, the defector gets 5, the cooperator gets 0. The Nash equilibrium occurs where no player can improve their payoff by unilaterally changing strategy. Here it is defect with payoff 1-1, even though cooperate is socially better. By adding a power dimension, say a senior member can impose a penalty on defectors, the payoff for defecting drops, shifting the equilibrium toward cooperation. Such models help explain why formal authority or incentive structures are needed to align individual incentives with team goals. Explanation: when faced with an exam case about power and influence, follow a clear blueprint. Situation: briefly describe the organizational context, size, industry, key players. Task: identify the specific power-influence problem. For example, a middle manager lacking formal authority but needing to drive change. Action: apply an analytical lens. Choose a relevant power base expert, pick an influence tactic, rational persuasion, map it using the power-influence interaction matrix, and support with social network analysis metrics high betweenness. Mention any ethical check cost-benefit equation. Result: quantify the outcome. For example, adoption rate increased from 40% to 75%. Return on investment $12,000. Reflection, discuss what could change if power dynamics shifted. For example, loss of expert credibility. Using the STAR format plus explicit reference to the models studied,